is called the differential operator. Differential operator. It's the way of saying take derivative. It is the symbol that says take derivative. Just like when you see a plus sign, it means add things. You see a minus sign, it says subtract things. You see a times, it means multiply them and whatnot. This thing means take derivative. So if I want to take the derivative of g, the way you would write it is this. dg dx, right? You have the d dx applying itself to the function called g. And this will equal the derivative on the other side. d dx of 5x squared. Okay? You have yet to take the derivative. This notation will be helpful when we get to more complicated rules. Okay? So we're just trying to introduce it with the simple rules. d dx of 5x squared. What does it mean to take the derivative of 5x squared? Well, this rule here, the constant multiple rule, says the derivative, in a sense, bypasses the constant. So I could make another step to this. Obviously, these are so simple and neat steps, but just to exhibit this for later more complicated problems. 5, right, the derivative operator, this thing, will bypass the 5, and it will apply itself to the x squared. What's the derivative of x squared? 2x. This is the most drawn out. This is the most drawn out that this could possibly be. 2x, and then you get 10x. Okay. This is the most extensive work you can do in computing such a very small derivative. But I want to make it clear how to use this operator for other more complicated cases. Let's take another example. I lied. Let's write another rule, and then we'll take another example. It's called the sum or difference rule. This one is so great. Now it'd be horrible. If you have a sum of or difference of two functions, f of x, I'm going to write plus or minus, whichever one you have, it doesn't matter. Then the derivative is simply plus or minus the derivative of each one. So that's fantastic. Okay? That's the derivative. So what does this get us to now? It gets us to polynomials. With these few rules we now have, we can differentiate, that is, take the derivative, that is, find the slope of any polynomial we want. Okay? Let's write a quick example. Let's say that h of x is 5x to the 9th minus 4x cubed plus 2x minus 1. Okay? Let's say we have that function now. This is much more expected than these small ones that we given. You have something like this. You want to take its derivative. You want to find its slope anywhere. Okay? That's what we're doing right now. Slope anywhere. So then I will apply the d dx operator, right? My derivative operator, to the function h. So I want to find dh dx. This notation is meant to connote change in function h over change in variable x, right? Change in y, change in function over change in x. The slope, right? Change in y over change in x is the slope. That's what this is meant to connote. That's why Leibniz came up with this notation. Equals. So I need to apply the derivative to both sides. So d dx of this expression. Again, if you already know how to take these rules efficiently, then what I'm writing is very laborious. So I'm doing this for the students who do not know how to take these derivatives so directly. Okay. The sum difference rule states that I can move this operator onto each of these 4 pieces. All I'm doing is adding and subtracting each of these pieces, so the derivative applies itself to each term directly. Okay? That's what this is trying to say. You got something like this, its derivative is this. So we can move from here to d dx of 5x to the 9th. You will not want to do this. I just want to, meaning after a few rounds of this, you won't want to do it like this. I just want to show you how this kind of really works using the rules. 4x cubed plus the derivative of 2x minus the derivative of 1. Okay? All I did so far was use the sum or difference rule. And I applied the derivative to each term. All right, so now I got to take the derivative of each term. Well, if I take the derivative of 5x to the 9th, according to the constant multiple rule, the derivative is going to bypass the 5 and apply itself to the x to the 9th. So you can probably tell me in your head already what the answer is.
5x to the 8.
Exactly. I'm going to write it out. how this proceeds in a very official manner here. D dx x to the 9 minus 4 d dx